Hello and welcome to today's event on Microsoft Azure, or more specifically entitled, Rapidly Launch Delightful Mobile Apps Using the Cloud. I'm Scott Mutzelfeld, and I'll be your moderator today, and I want to thank you for taking time out of your day to join us. On behalf of responsiveX, our speaker, Eric Boyd, and our sponsor, Microsoft, I'd like to welcome you. Before I hand this over to our speaker, Eric Boyd, I'd like to get a few simple housekeeping items out of the way. First of all, let me say that we'll welcome questions during Eric's presentation. I know Eric has a full agenda today, however, we'll try to get to questions as we can throughout the presentation. There is planned time, however, about 10 to 15 minutes for a Q&A at the end as well. If we don't get to all the questions in time that we have, then we'll work to respond outside of the event as well, even if we run a little late today. You can ask questions using your Q&A window on your screen. There is a common question that surfaces often, and I'd like to answer that ahead of time. Yes, this presentation will be available on demand. We usually get the sessions posted about 24 hours after it's live. You'll be able to find the presentation at one of these three locations. First on the responsiveX website, which is www.responsiveX.com, or on their YouTube channel, which is youtube.com/responsiveX, or on their Facebook page, just a quick search for responsiveX, one word. Okay, today's presentation focuses on a really important topic. It's a given these days that mobile apps are a must-have for your business. They make your products and services accessible anytime by everyone, everywhere. But how do you quickly create your needed apps for all of your customers across all of their platforms and devices? Today, your mobile users expect common capabilities in your apps like logging in with Facebook and other social media providers. They expect their data available across all their devices, including iPhones, iPads, Android, Windows, PCs, and others. And they expect personalized notifications when important events and promotions occur. Building these back-end services for your app typically requires a big investment, takes extended amounts of time, and ultimately delays your product launch. Luckily, the cloud and Microsoft Azure, which is formerly Windows Azure, has made it easy to build these robust user experiences with Microsoft Azure Mobile Services. In today's webcast, Eric Boyd from Chicago and Milwaukee-based responsiveX will show us how to offload the plumbing and server development of your mobile apps to Azure Mobile Services, which enables you to focus on creating the best app user experience and functionality for your users. Using Azure Mobile Services will save you time, money, and get your app into the hands of your users faster. In addition, your server backend will be available to all of your users across the vast mobile devices and platforms available, including iOS, Android, Windows, and even the web. If you're not familiar with Eric, he is the founder and CEO of responsiveX, one of just a select few Windows Azure MVPs, and a regular speaker at national conferences, regional code camps, and local user groups. As a result of his passion for technology, apps, and cloud services, he founded responsiveX, where he helps customers with management and consulting to build outstanding web, mobile, and client experiences using the cloud. Simply put, Eric lives in the cloud. He launched his technology career almost 2 decades ago with a web development startup and has served in multiple roles since, including a developer, consultant, tech exec, and business owner. You can find Eric blogging at www.ericdboyd.com and on Twitter at twitter.com/ericdboyd. Having said that, and without further ado, let me turn the presentation over to Eric. Eric?
Thanks, Scott, for that great intro. Like Scott said, I live in the cloud. I spend a lot of time, most of my time, helping customers here at responsiveX build applications in the cloud. And just a brief overview of our company, what we really do is help customers from all the way from an architecture and design perspective through implementation and management, build applications, whether that's a web app or a mobile app or even a thick client app, client-server sort of app. And generally, it's all built around cloud technologies today. So we spend a lot of time doing that, and we love the cloud. So with that, I'm going to give you a brief kind of picture of what we're going to talk about today. It is going to include the cloud, but we're really going to focus our attention on mobile. And the mobile space is, like Scott mentioned in the intro, it's critical for most businesses. Um, our users have expectations of our businesses, not just our mobile apps, but of our businesses, and oftentimes that means they need access to our data or some functionality in a mobile way all the time. And so we'll talk about the expectations our users have briefly, and then I'll give you an overview of what the cloud and Azure is all about, and then we'll drill and dig right into what I in the industry refers to as Backend as a Service, mobile Backend as a Service, and specifically Microsoft's implementation of mobile Backend as a Service with Azure Mobile Services. And like Scott mentioned, I'm going to try to leave some time at the end for questions. We have a lot of things to cover. I'm not going to cover everything in great detail either. So if there are things that you want to know more about and learn more about, feel free to send us a message. Put it in the questions pane or the chat window as well, and we can certainly spin up other sessions like this to drill in more detail on specific areas. So with that, let's talk about mobile. Now we kind of all know why mobile is important. I think we all know why mobile is important, but this is a quote from Gartner. It's probably a year or two old at this point, but it was looking at 2013 and the size of the mobile app kind of ecosystem in space at the time. And so in 2013, Gartner predicted that there would be 21.6 billion applications sold, generating almost 30 billion in revenue, $30 billion in revenue in 2013. 25% of the revenue, interestingly, wasn't even from the mobile apps, but was from advertising in the mobile apps. So the whole Google ad model exists not just in the browser, but in mobile apps as well. And we build apps today that have that sort of model of revenue generation from just ads and free apps. So the mobile app space is big, but to further quantify that, let's look at a couple of really big success stories. Maybe these are stories we know of, but Draw Something is a game built by or owned by Zynga at this point. Zynga bought them for $180 million, and it's been a while since they made that acquisition, but a game is maybe not accurate. It's a social drawing sort of game. And so if you know Zynga, Zynga is the company that makes Farmville and all of those sorts of Facebook games, and they did the same thing with a mobile app called Draw Something, where we would collaborate and draw something together on our mobile apps. So they purchased that for $180 million. Now that's interesting. That's a lot of money. I would be happy to sell a mobile app to a company like Zynga for $180 million, but it gets bigger. And so this is another good canonical example of a very simple app that's been purchased by a company like Zynga. In this case, it's Facebook, but Instagram, $1 billion acquisition. That's a big deal. So I would be happy at $180 million. I would be really happy at $1 billion, but it gets even bigger. And so we look at companies like WhatsApp. And WhatsApp was such a simple application, and if you've used WhatsApp, it's not even I don't think it's a beautiful application either. It's basically a text messaging app that doesn't use SMS networks. It's a Facebook-style messenger app. Facebook bought them for about $19 billion, and that's a really good day for the folks that built WhatsApp. So the mobile space is huge, and you see these, there's lots of money to be made just in your mobile apps, but there's also lots of money in acquisitions. And why is that? And so our users have some pretty big expectations today. They expect to interact with our companies in lots of ways from lots of places. So, for a long time we've had a telephone and mail, and we've interacted with individuals and companies that way. We've progressed to things like email and text messaging, but now we want to do more than just communicate. We want to get information and make buying decisions and solve problems with devices, with mobile devices. And so our users expect to be able to do that, not just from their phones, but they expect to do that from their browsers, their desktops, and even today our entertainment and game consoles. I don't know how many of you guys use game consoles like PlayStations and Xboxes, but I spend a lot of time not playing games, but with my game console running, things like Netflix and Amazon Instant and stuff like that. So kind of bridging those together and being able to gain insight and interact with our businesses from those devices are really important today. So our users expect this. In addition, they expect some other things. They expect our apps to be responsive and quick. They expect them to always be available, and so they expect them to be reliable. You expect when you open Facebook that it just works. You don't even think about it not working, but it would be a big deal probably for you if Facebook just stopped working for a long period of time. That's a painful thing. And those are simple examples. Those aren't mission-critical sort of examples. And kind of piggybacking on that idea of cross-platform, across multiple devices, across multiple platforms, we expect a continuous experience. And so when we're using Facebook on our phones, we don't expect that to be isolated to our phones. We expect that we will pick that up in a web browser, and Facebook will have all the info we created on our phone in our web browser. And if I were to go to my Xbox and pull up YouTube, I would expect the same videos on my Xbox as I would get on my phone and in my web browser. And so we just expect that kind of thing as users. But there are a lot of apps out there that don't provide that experience for our users. There are a lot of apps that provide an experience that's just sandboxed to your phone, and nothing is collaborative across devices. And there are a lot of apps that are just isolated to single platforms. And so those are not the experiences our users kind of expect and demand today. Now, providing those experiences it's not easy. So I'm not going to tell you that this is a very simple thing to do, because it's not. There's cost and time developing apps that are cross-platform. And there's ways to minimize that cost and make it less painful, make it easier. So things like PhoneGap and Apache Cordova make it possible to use web development technologies and build applications that will target multiple devices, including iOS, so your iPads and your iPhones, or Android, tablets and phones, Windows phones, even BlackBerries and other devices that are not what I would think of as big market share and mainstream today. So there's ways to do that with tools like PhoneGap, and you can use the web frameworks that you know and love, like HTML5 and JavaScript and CSS. So the same sort of stuff that you can do in the browser. The great news about using a tool like PhoneGap and Cordova is that with that, you can use and repurpose that same stuff, that same code, to run in your browser. And so you can build mobile apps or websites and mobile websites with that same code base. Now, in addition, there's other tooling to do cross-platform native development as well, things like Xamarin, which is a tool that lets Microsoft developers build cross-platform mobile apps using Microsoft technologies that you can target iOS and Android and Windows as well. And so there are a number of ways to do that. And you could also build each app individually with the native platforms. So you could build an iOS app with Objective-C and Xcode and using the native iOS platform. You could build an Android app using Java and whatever Java tooling that you like. And you could build Windows Phone apps and Windows apps using the native Microsoft Visual Studio tooling and the native Microsoft languages. So there's a lot of ways to skin that cat. The other challenge that we run into is infrastructure. So if you're a mobile developer, you might be really, really good at building a great looking and a functional mobile app. But you may not have the server-side skills to build web services and web APIs and to build platforms on your server to do back-end processing. So if you're thinking about something like a Flickr or a YouTube and you're uploading video, there's a lot of stuff that happens behind the scenes, encoding that video to multiple formats so that it renders and streams well for everyone. Maybe it's photos and you're resizing photos on Flickr or something along those lines. So there's a lot of things that you may want to do on the back end. And so just the implementation of that can be difficult. But beyond that, the cost of buying servers and buying space in a data center and all of that and managing all of that can be a showstopper for folks wanting to build mobile apps. And so that's really where we're going to focus our time today. We could spend tons of time talking about how we could do this in a cross-platform way across multiple devices, but we're really going to focus on that back-end infrastructure and how we provide those great continuous mobile experiences using the cloud. So with that, what is the cloud? And the cloud is one of those terms that's really overloaded today. It means a lot of things to a lot of different people. And so I'm going to try to distill it down very, very concisely for us. When I think about the cloud, it's really providing internet scale compute resources to multiple devices, multiple platforms, making it accessible everywhere so that we can just quickly, on demand, in a pay-as-you-go way, buy data centers, if you will. So I can have servers running in a cloud data center, and I just pay for the servers and the time that I need. So I don't make big investments up front to build out that massive data center. Somebody's already done that for me, and they're just leasing me or selling me, renting me that space. And so that's what the cloud's all about. And Microsoft Azure is one of the leading cloud providers today. There are multiple cloud providers in this space. There are companies like Amazon and Google also in this cloud space. But Microsoft is doing things a little differently in the cloud space and providing a lot of interesting value-added services, which we're going to talk about today a little bit. So at the core of Azure, there are really three big areas. There's compute, and there's places that we can run our servers. So we can run servers, and we would call those virtual machines in Azure. We could have platform as a service offerings, so things like I just want to deploy a simple website to Azure, and we can do that. And then mobile services really kind of lives in that compute space in a lot of ways, and so it's a place where we can host up our back-end services in Azure. There's also storage services. So I want to store files. I want to store structured data as well. So think of maybe logging data or something like that. And I could use Azure Storage for that. And then last is relational data services. So if you are familiar with SQL Server, running a SQL Server kind of as a service, you don't have to manage any of that hardware in the OS, and the SQL Server installation is really what this database service is a database as a service, so we don't have to manage any of that infrastructure. Now, when we think about scale and providing these services at mass scale, it's more than just lots of servers in a data center. It's providing that in a way that's available around the globe and available in the event a data center would go down or there's a natural disaster or something along those lines. And so we have lots of Azure data centers to choose from, and you'll see in this diagram these blue dots represent data centers, and these are not. This is not the most current. So this diagram shows 8 data centers around the world, and in 2014 we will have 16 data centers. So right now we have 2 more in Japan and 2 in China, in mainland China as well, and we're adding more all the time. We're seeing more added by Microsoft all the time. And so 16 in 2014 is what we're looking at for data centers around the world. And then in addition to those core services, there are also building blocks that we can use to build apps on top of this platform. And so we talked about database a little bit and storage, but there are messaging services, there are services for encoding video, stuff like that. And so these allow us to just kind of build our applications and focus on our applications and consume those services in our application. All right, so with that, one of the common scenarios we see and run into that's perfect for the cloud is mobile backends. And specifically using Azure Mobile Services, that's what we're going to talk about today. But this is a quick diagram to give you a picture of what that looks like. And so we're building cross-platform mobile apps on the client, but we need services like push notifications. Our users expect to be notified of events as they occur. So we get those nice little pop-ups on our phone to say something has happened, go check out this app. Maybe it's a message on Facebook or something along those lines. I'm using Facebook a lot today, but those kinds of scenarios. I expect social integration as well. So I expect to be able to log in with social providers like Facebook and Twitter and that sort of thing. And I expect to save data back to a centralized data center so that multiple devices, whether that's my phone and my tablet and my PC, or maybe that's collaborating with other users, I need that data to be accessible and stored in a centralized place so that multiple devices and people can see that data. So with that, let's take a look at what mobile services is all about. The mobile services SDK and the framework really begins with a REST API. If you're familiar with web technologies, REST is a term that you're probably familiar with, and that just means I have web APIs that I can consume that are designed to use HTTP in its kind of native form. And so I have these web APIs that I can go use for my applications, but in addition to that, Microsoft has done a great job of building native clients for us to use as well. And so you'll see I have pretty much everything I could want to use. Every platform that I would want to build a mobile app on, there's a native API for a native SDK. So Windows Phone, iOS, and Android. There's even clients for HTML5 and JavaScript. And there's clients for things like Xamarin and PhoneGap. And so pretty much anything that I would want to build, there is a client for, and I can use mobile services. So with that, let's go just open up Windows Azure and take a look at how we would build a mobile service today. So if you're not familiar with Windows Azure, let me show my screen here. All right. If you're not familiar with Windows Azure, you can get to Windows Azure by going to azure.microsoft.com. And this is the friendly website for Windows Azure. And I keep saying Windows Azure is going to be tough for me to break that. There was a rename that occurred a couple months ago, maybe a month ago now, to Microsoft Azure. And so if you hear me say Windows Azure, I mean Microsoft Azure. It's just a habit that I've developed since 2008, and so it's going to take me a little while to break that one. But this is the Microsoft Azure website. There's all sorts of great info about Microsoft Azure here, including pricing information and all of that sort of stuff. You can set up a free trial as well if you're curious and want to kick the tires, and so it's very easy to just go through a simple process to set up a free trial, and you get a month of Azure for free, $200 to spend however you want in Azure services, and kick the tires and get started. What we really want to do is go to the portal, and I've already loaded up the portal over here. And so I'm going to go back out to the mobile services section of this portal. If you're familiar with Azure, this is familiar to you. If you're not, what you see down the left-hand side is a list of all the services that we have access to. We're focusing today on mobile services, but there are a lot of services that you have access to in Azure to build applications on. Now, in the portal, there's a button at the very bottom that's a new button. It exists pretty much everywhere. And it's very easy for me to just click new and say I want a new compute service, I want a mobile service. Let's create that mobile service, and we name that. And so in this case, we might name it mobile to-do list. That's already taken. Let's call it webcast mobile to-do list. Perfect. And then we want a database to store all of our data. And so when we create our mobile service, it asks us, how do we want to do that? We can create a database that's free, a free 20 meg SQL database. We could choose to create our own SQL instance here and do that manually as well. In this case, I am going to say create a free 20 meg database. I've already done that, so it won't let me do that. So I can say create a new SQL database instance, and I can choose my data center next. And you'll see I have multiple data centers to choose from. Back to that diagram we saw earlier, I'm going to choose the data center in the US on the East Coast. And then the last option we have is how we want to code up our backend, like what technologies do we want to use. And so mobile services started out with JavaScript. That's familiar and a common language for lots of developers, not just Microsoft developers. But there's now also a Microsoft kind of flavor of this as well, and so there's a .NET flavor of the backend that's in preview. In our case, we're going to just choose JavaScript, and we're going to click Next. So the next thing it's asking me for is my database information, and so there's the name of my database. I can choose a server, and I'm going to go ahead and just let this use an existing server that I have. And then I'm going to click the check mark, and it's going to go ahead and create our mobile service. And it's just that easy. In this case, it did not like my credentials. but had my login worked successfully, you would have seen a new mobile service appear here. Now I just created this right before this webcast, and so this is an existing mobile service called Developer To-Do List, and this is the one we will use as we go through here. All right, so let's take a look at a mobile app. Now what I have here is a very simple mobile app. It's actually a web app, but it could be easily a PhoneGap app that I would deploy to natively to devices. In this case, I'm just going to use it in my browser because it's easiest for us to demo it here in this webcast. But what I have is just a very simple to-do list app. And so I want to add items to my to-do list, and I want to say I want to add a mobile backend for our to-do list. And I'm going to add data services, so I'm going to add some data APIs. I also want to do things like authenticate users. And so we've created our to-do list. Now, the typical challenge with mobile apps, and we've talked about this a little already, is that this might be sandboxed to my mobile app and not shared anywhere. So I have a to-do list, but it's on my phone, and that's the only place that I can get it. In some cases, I'm not even persisting this data anywhere, like even on my phone. So next time I load up this app, this data is gone. And that's what we've done in this case. So this app is running just fine right here in my browser. But if I refresh, all of my data is gone. And that's exactly what we don't want to have happen. And so we want to make this app use our mobile service. And in doing so, we want to provide some rich capabilities for that to save our data, authenticate our users, and that sort of thing. So I'm going to go into our mobile service, and the first thing I'm going to do is delete a table that I already have in my mobile service just to kind of clean my slate, and we'll get started from scratch here. So I have an existing to-do item table that I built up just a little bit ago, and I'm going to delete that, and so we can start from scratch. I'm also going to go into Visual Studio, and you could use whatever IDE you would want to use to edit HTML. But in this case, I'm using Visual Studio because it's just what I like and what I know. But I have this simple HTML for that mobile app right here in Visual Studio. And so you'll see here's everything in that app. So I'll change this to just show that this is the same code. So this is our webcast developer to-do list. So if I go back to our mobile app and I refresh this, it should say webcast developer to-do list. So this is in fact the same code. I'm going to save this. Now the first thing I want to do is make this app aware of mobile services. And so I'm going to add a JavaScript library to do that. So over in my toolbox, I have some code snippets here. And so I'm going to use that, drag this in, and I've added a reference to the mobile services JavaScript library. So I'm going to save that. If I go over to the JavaScript that's backing my my app right now, you'll see that I'm just storing all of those to-do items locally. And so I have an array of items, and that's what I'm using to store all that data. So that's why when I refresh, my data goes away. So what I really want to do is back that data and store it in Azure. So the first thing I'm going to do is copy over a reference to, I'm going to create a variable to our mobile services, well maybe, I'll just do it right here, to our mobile service. So I'm going to say give me a client here. I'm going to get rid of those two variables that we were using right here. So I have a reference to that mobile services library right here. If I go back to our mobile service and I go out to the dashboard, you'll see I have a URL for our mobile service right here. I'm just going to copy that and I'm going to paste that right in here. Now the next thing I need is a key. So I authenticate back to my mobile service using kind of a secret key. And so I'm going to copy that secret key to my clipboard, and you can get to that by clicking this button at the very bottom of the Azure portal. And I'm going to paste that in here And now I can authenticate to my mobile service. All right. I got rid of static items, and so I need to get that data from somewhere. So I'm going to get rid of this refresh to do items function, and I'm going to replace it with a function that gets data from mobile services. Now I also, right above that function, I'm going to add some very simple code to go get the to-do item, the list of to-do items. And so using this mobile services client, I'm saying get table, and there's my to-do item table that's out of my mobile service. Now we deleted that, so we'll go back in and create that. But I'm going to get all of the data from that to-do item table. Now you'll see in my refresh to-do items, I have a query that just gets that table, and then I read that query and I populate a list of to-do items in my mobile app with the results of that table. Now in addition, I need to be able to add items. And so right now our add item function here using jQuery is just adding items to that local array that we deleted. So I'm going to get rid of this code here and add in a new function that's almost identical, except instead of adding it to that static items array that's just local, I'm now adding it to this to-do item table. So back up at the top, I have this to-do item table reference, and I'm going to add and insert items into that table. I'm going to do the same thing for updates, and so I'm going to quickly just go through these items and replace this code with the code for updates and deletes. And it's just doing the same thing and referencing that to-do item table object. In this case, it's calling a delete property or function, and in this case, it's calling an update function. So I'm going to save all of that, and I am going to go back to our mobile service, and I'm going to add a table. So right now I have no tables. I'm going to add a table, and we're going to call it to-do item. And we can set permissions on this table. So we can say anybody with the application key can get to our table, and that's what we're going to do for right now. So I'm going to click OK. It's going to create a table for us. And once that's finished, I can run my application and add items into this table. Now if I open this table right now and I browse it, you'll see it has, it doesn't have any records. We haven't added anything into it yet, but it has some columns that exist just automatically. And so Azure Mobile Services creates a couple of things for us. It creates a primary key and creates an ID column. And then it creates some additional metadata of when this record was created and updated in a timestamp, a version timestamp as well for that table. But right now there's no records. And I also haven't designed the table. I haven't done anything to shape this table and say, here are the fields that I want to store. That's one of the great things about mobile services is that it's dynamic. So if I go back to my app and I refresh, if I coded this up well, we should see this work fine for us. All right, there we go. So in our mobile app, it's pulled back 0 items because there's no items in our table. But if I add an item and I go back in and I say, I want to add a mobile backend, and I add that, and I want to add data APIs, and I want to authenticate users. So now we have 3 items, and this time if I refresh, that data is still there. It didn't go away. So very simply, by adding just a little bit of JavaScript to my app, I was able to save that data out in Azure without doing anything besides creating a new mobile service and adding a table. Now if I go refresh this table, we will see those 3 records: add mobile backend, add data APIs, authenticate users. And it added in for us these 2 columns, text and complete. And so we didn't have to do anything to do that. Mobile services is dynamic, and the schema will get populated automatically for us. So then if I wanted to delete one of these things, I could say, in this case, I could just check this. If I refresh this page, it should have gone back out to my mobile service, and completed, mark that item as complete. And so there we go. Now that's complete. Add mobile backend. I could also delete that item. And it's gone as well. So very simply, I was able to build a data API. And again, it's all based on REST. And so let me show you what that looks like. So when we created our to-do item table, what we got was a mobile, a RESTful endpoint for our mobile app. That was our mobile service name .azure-mobile.net/tables, and then to-do item. And so you'll see I have typical CRUD operations in a RESTful way, so I can post to that URL and add or create to-do items, which is what we did for our mobile app. I can read using the get verb. And I can even query that because it's got an OData endpoint basically, and so I can query that as well by adding some filtering capability on the end of that. And I could do a patch for an update, and I can do a delete as well. And so that's what I get for an API. I'm going to pause for a second because there are a couple of good questions here. And so one of the questions is, can we change the database type later? So can we start with a free one and migrate to a paid one as well? And so with mobile services, what happens is you get a 20 meg database for free. It's your database. It's your SQL database instance. And so that data we just created and stored, it's actually in a SQL database table for us. And so let me page to the next screen, and we'll talk about that a little bit. But that is your database. And so you can scale that up as you need. You can grow that from 20 megs to, right now you can have SQL database sizes up to 500 gigs. So you can grow that as you need and as your app needs. What happens under the covers is you have a database for your mobile service. Now you could use multiple mobile services with your single database because it uses kind of a full schema in how it names your tables. So you'll see here if we had two mobile services, we had app X and app Y, we would have a schema in our SQL database that was prefixed with app X, so it keeps those in isolation. We can have two tables with the same name across two different mobile services in the same database. And I can manage that database. It is our database, and so I can manage it with all of the same SQL database tools that I know and love, like the Azure portal and SQL Server Management Studio, and there's REST APIs and that sort of thing. Now what's going on the server? On the server, that JavaScript is being executed by Node.js. So that JavaScript on the back end is running in a Node.js runtime. Mobile Services is automatically creating these CRUD endpoints for your tables, going all the way back to SQL Server, but I can jump into that workflow into the insert, update, read those CRUD operations into those web APIs and add my own custom logic as well. And so I'll show you that here in just a little bit. In addition, because it's Node, there are multiple NPM modules that are already included, things like request and push and status codes, all are NPM modules that you may use already. But because it's Node, I can also install third-party modules using NPM on the server as well. So if you're familiar with Node.js, this is familiar to you. If you're not, it's not critical. It's just JavaScript kind of on the back end so that you can just kind of write JavaScript and execute that without having to understand all of the core server technologies behind the scenes. So with that, let's take a look at those server APIs. All right, so back over in my browser, I am looking at my Azure mobile service and my to-do item table, and you'll see I have this script tab or script page here. Now, one of the things I may want to do is validate the data going into my to-do list app. And so here is, in that script page, I have a drop-down of all of the CRUD methods here, so insert, update, delete, and read. And I can go in and customize the logic in here. And so I could say something like, let's just write some code. If item.text.length, so that's our text, the text for our to-do list items. Let's say if that's greater than 20 characters, then we want to, using the NPM request module, we want to respond, and we want to use the status codes module. Now, the cool thing is I have some IntelliSense here, so I can just control space, and you'll see I have status codes. So that's really a nice feature. And I can do this and say I want bad request. And what I want to do if there's a bad request is I want to have an error. I want to say to-do item name cannot be longer than 20 characters. I'm kind of scrolling over here, so let me do that. And I'm going to close this up. Now I also, if it's less than 20 characters, I want to continue on and execute my request. So I'm going to leave that just like it is. I think this looks good. So now if I save this, I've updated my script. If I go over to my app, I should be able to just say add a lengthy to-do item to our to-do list. And if all is well, let me refresh this. There we go. Add a lengthy to-do item to our to-do list. It should prompt us with an error. And it's not. So let's see if I missed something here. I did. So what we want to do is, right now we're not validating this in our client. It is erroring, but we're not seeing that error. And so I'm going to replace this code here with some validation code on our client. So I'm going to delete that. And so now what I have is just simply, when I insert, if there's an error, then do this, which is, it's just going to alert me with the response. So now if I go back to my app and I refresh, I should be able to say add a lengthy item to our to-do list. And if I could spell, there we go. And now it's giving me an error. Now those other items didn't get added because the validation is not on the client side. So if I go back and look at our table, those other items, when it failed, it just swallowed up our exception for us. But it didn't add those items, and so it did do the validation properly for us. So all that's happening on the server side in JavaScript. If I go back to that insert JavaScript, here it is, very simply. I could easily now, even though I have that validation in my client, get rid of that validation logic, save this, and then go back to our app. And then this time it should add a lengthy item to our to-do list. It should add it just fine. Maybe. There it is. So it did add it. If I refresh over here, it should be here as well. So you can see that validation on the server is very simple for us to do. We can kind of jump into those server APIs and add whatever logic we would want based on the request and then the user and the data coming in. So we'll take a look at some authentication here in just a second. All right, so now we want to authenticate our users. So right now it's kind of a free-for-all. Anybody can use our app, and we don't require them to log in. We don't have any permissions either on the app. We're just saying anybody with our application key can use it, and that may work for some applications, but we want to be able to authenticate users. And so we can use a lot of authentication mechanisms. We could use Twitter, Facebook, Google, Microsoft account. We could create our own custom authentication mechanisms as well. We can set a lot of different permissions as well for operations. And then I can do things inside my, my scripts as well to deal with authentication. And so with that, I'm going to go back to our portal and show you how we can quickly authenticate users. So I'm going to go back to our mobile service, and if I go to the Identity tab, you'll see I just have options to plug in credentials from things like Facebook and Twitter and what have you. And so I've already created over in Twitter, I've created an app very simply at apps.twitter.com. Here's my my tokens. And so here I want to copy this API key and secret and just paste that right into the mobile service for Twitter settings and save that. So I've already done that, but that's all I've had to do was add that into the Identity tab. And now my mobile service is tied to Twitter, and I can use that as an authentication provider. I could also use Facebook or Microsoft accounts, and I can use them together as well. I'm not bound to just using one. So now if I go back to my API, I want to authenticate and require users to be authenticated to use my API. So if I go into the scripts for where I insert data, I can now say when I insert, also add the user ID to that record, and then I'm going to save that. And then when I get my data back, so when I read my data, I want to filter it based on the user. So here I can say, let's query this where the user ID is equal to the user ID, and so only show me that data. So now if I go back to my app, it should return nothing because there aren't any, I'm not logging in with the user. It might even error out for me here. I'm not logging in. It doesn't have a user ID. There we go. So I have 0 items. Even though we just had 3 items, and there are 3 items over here in this table, it's not returning any because it can't filter it based on that user ID. So we want to allow our users to log in. So I'm going to go back to our app, and I'm going to add a couple of login buttons here at the top of our app. Just a couple of lines of HTML to give us a login and a logout button. And then I'm going to go down to the bottom of our JavaScript, and I'm going to replace this refresh to do items with a few JavaScript functions that will go and authenticate us. And so the first thing it's doing is it's saying using the mobile services client, log in with Twitter, and then call this refresh display if all is well. If not, it's going to alert with an error. And if all is well, then it's going to say I'm logged in, my current user. If my current user is not null, then I'm logged in, and it's going to hide and show the login, logout controls. It's going to display our login ID from Twitter, and then it's going to refresh the to-do items. So very simple JavaScript here. It's also, I have a logout function as well. So I'm going to go load up my to-do list again, and you'll see I have the ability to log in. If I click log in, it's going to take me out to Twitter and ask me if I want to authorize, and I do. And now you'll see there's my Twitter ID for my user. Now I still don't have tasks here because the tasks that we added, the to-do items, were under a different, they don't have a user ID. So if I add a new to-do item, you'll see my new to-do items added. And if I go open up my mobile service, you'll see that my schema got updated, and I now have a user ID, and there's my ID that's getting persisted. And so now if I log out, you'll see there's all of the items that don't have a user ID, that don't require authentication. And then if I log back in, you'll see the item that did require authentication. That's my item. So very simply, I was able to add Twitter authentication to my mobile app and then just do some simple logic inside my script to tie these work items or these to-do items back to me as a user. Now the last thing that I think is critical for mobile apps is push notifications. And I'm not going to demo using push notifications, but I'm going to show you how it works in mobile services. Now just like identity, we do the same thing for push notifications, and we can integrate with multiple providers. So I can integrate with Windows, the Microsoft push notification service, Apple or Google GCM as well. And there's a simple API that's consistent across all the providers. That's push star, which is the push provider, and then send. So that I call the send function on the push module, and I can send push notifications. And so I can have some back-end services sending push notifications running on a schedule or something like that, or an event-based back-end service as well. So with this, just some quick examples of how this works. If I wanted to send what's known as a toast in Windows Phone, which would be just kind of that text message sort of alert, I would say push.wns, and this is actually not, this would be on Windows or Windows Phone, the later versions of Windows Phone. And I could send the toast text, I could call that function, and then that has the toast message that I want to send. If I wanted to do this for older versions of Windows Phone, then there's a service called MPNS, and I can do the same thing here. In this case, I'm sending a flip tile notification, so it's flipping the tiles on the start screen. I could do it again with Apple's push notification service, so APNS, and so in this case I'm sending that device token, and the structure of the message is a little different. I have alert with the message, and then a new payload for the in-app message. And then for Google, again, it has a little different structure, but the core functionality is the same. The core structure of the function is the same. It's push notification service.send. So very simply, I can create push notifications. If I go back out to the portal and look at my mobile service, what you'll see is just like identity, all I have to do is plug in my push provider, the settings for my push provider. I can then call those services within my APIs or within a back-end service and send out those push notifications. So we've looked at the data services that get persisted back to a SQL database table. We've looked at identity, and we've looked at push. There's also ways for me to create APIs that are not tied to data. So maybe I have some sort of functionality that I want, some calculation, something along those lines. I can create my own custom APIs using this API tab, and it gives me the same sort of experience. I can name my API, so maybe it's calculate, and once I'm inside this calculate, I have a scripting window just like inside the data APIs that I can kind of code up my my method. So there's a raw request, and there's my response, and I have a get and a post here. I can set permissions as well on that API, and I can use the other HTTP verbs here as well. In addition, I can also schedule work to run in the background. And so I may have some sort of job that's running every hour that's doing some calculations and then sending out push notifications based on that. And so in mobile services, I can also do that pretty simply. Now, we want to be able to reach all of our users, and sometimes that may have peaks and valleys in terms of load and demand. And so with mobile services, just like pretty much everything in Azure, I can scale this. And so I start with this free tier. I can scale this up and say I want to scale this to a basic tier, and I can go to even larger tiers and scale this up and have and I can configure the amount of API calls that I want. So there's my unit count. I can continue scaling that to meet my demand and my users. In addition, I can look at logs. So I'm not going to save that. And I don't have any logs right here, but in our APIs, if we were to do a console and use the console module and log things out using the console module, we would see all of that appear here. And so I can still get telemetry and diagnostics data using that JavaScript API. All right, so with that, how much does this cost? This is always a question. And so you'll see here, there's a great pricing calculator at azure.microsoft.com, and you can go configure whatever you want in Azure, but you can say I want a mobile service. Let's quickly just break out to that, and I'll show you what that looks like. I go to Pricing, Calculator, blow this up here. I want a mobile service, and then there's the free tier, and if I want more details about the pricing, I can click Learn More here, and it will give me all of the pricing info on how it's calculated. So there's a free tier. I can have 10 services, 500,000 API calls with 500 active devices, and then I can scale that up as my app grows and as I need. But this nice calculator allows me to just kind of dial in some things and say, okay, I have a 1 gig database instead of the free 20 meg database. I want a basic mobile service with 1.5 million API calls a month, and that sort of thing. I can just scale it up as I need to, and calculate that price. So pricing always comes up. I want to also mention a couple of other things. If you are in the Chicago, Milwaukee area, so mobile scenarios are one of the scenarios that are really common for us with Azure, but we've identified 10 scenarios that we think are the top workloads in Azure and in the cloud, and one of those is also dev test. And so we have a lunch and learn coming up in a couple of weeks. I think next week through maybe the first week of June in Chicago, Milwaukee, and out in the Chicago suburbs. So if you're in that area, feel free to join us for lunch. And there's the bit.ly link right there. It's bit.ly/devtesttour. But you can register, join us for lunch, and learn a little bit how to get started using Azure for dev test as well. And those 10 workloads that we've identified, here's a data sheet that you can download at responsivex.com/cloud-top-10 that identify those 10 common scenarios for using the cloud and Microsoft Azure. Yeah, but I hope everybody got some value out of this, and it's at least intriguing, and you're wanting to dig into to this a little bit more.
Absolutely, Eric. Yeah, just on behalf of the attendees, I'm hopeful that everybody found this informative. I know it was for me. I'm just really grateful for your time today and putting together this presentation. I think it's great. Yeah, that is all the time we have today, and I do want to thank everybody for attending, and I'd like to also thank our sponsor Microsoft for their support on today's topic. And Eric, again, thank you very much. Really appreciate it. With that, on behalf of Eric and responsiveX, I want to wish everyone a great day. Thank you very much.